morning.
Morning.
Good morning to you.
The birds
The-
are chirping.
All right, so we've spent some time the past couple days working on solving quadratic equations. We got to factor them. We did completing the square. We talked about the quadratic formula. Then we talked about solving cubic equation, things where you had x to the third power. And we did that with factoring by grouping or by sum and difference of cubes. Today we're going to be solving the cube root function. The cube root looks like the square root, but it has a 3 up there. And so let's talk really briefly about what this even really means, okay? So our standard square root looked for pairs of numbers, okay? So it was like playing a game of poker and going, I win when I have a pair of something. And I just list down all the pairs that I have. So in this case, I have a pair of 3s, and so the square root of 3 times 3 is 3, because that's what I have a pair of. A cube root is the same idea, except you're looking for triples. You're looking for a set of 3. In this case, I've got 3 7s, and so the cube root of 7 to the third power is 7, because that's what I have 3 of. Easy enough?
Yes.
Okay. This leads us right into, well, what do I do if I have x squared? How do I get the x by itself? To get rid of a square power? Square root. Easy enough. Well, what if I have a square root? How do I get rid of a square root? How did I get rid of a square power?
It's by
Square root. So how should I get rid of a square root? Square power. They're inverses. Just like addition gets rid of subtraction, multiplication gets rid of division, roots get rid of powers, and powers get rid of roots. So I can take the power of this root in order to get rid of it. Which means if I have a cube root, how do I get rid of a cube root? Cube power. So here, how did I get rid of a square root? Square power. How do I get rid of a cube root? Cube power. This works with any index that you have up there. So I could give you the 20 millionth root of something, and to get rid of it, you would raise it to the 20 millionth power. It's that easy. Let's play with some. Solve for x.
we do the square.
But what's the index? Is it a 2 or is it something else?
It's a cube.
It's a 3. So I'm going to raise it to the 3 power. So a third root, a cube root next to a third power, a cube power, they get rid of themselves. I'm left with x. And then on this side, I have 8 raised to the third power. Please make sure you use some parentheses so the calculator doesn't get confused. And then x is whatever 8 times itself 3 times is.
Miss,
Yes,
you just canceled them out.
I did.
X. Oh.
Yep, I did.
Like 12.
512, she says. And I'm going to believe her because I saw her playing with the calculator. It's this easy. The only way to make these more complicated is to add stuff. Like number 2.
There it is.
But here's the thing, is you're looking at the cube root. We don't care if there's stuff inside of it. Is the cube root all by itself? I don't care about the stuff inside. I'm looking around outside. It's all by itself. I don't need to like mow the yard or anything. We're good. The house is alone. I can get rid of it by taking the cube power. So we're going to raise everything to the third power, and it cancels, leaving me with the stuff inside, and then whatever 5 to the third power is. 100 and,
125.
oh, it's 125, thank you. And then from here it becomes the standard equation that we're all used to dealing with. Get x by itself by doing what? Getting rid of the 2. That plus 2.
On this side.
So subtract -2 to both sides, and x will be some number. 123, you said? It totally sounds reasonable. Again, the only way to make this more complicated is to keep putting more stuff, like number 5. Is the cube root by itself?
No.
No, so I need to get rid of the stuff outside of the cube root. What's outside the cube root?
-16.
The -16. I need to get rid of the -16. She said add 16 to both sides. I saw you doing the little add symbol with your pencil there in the back. Thank you very much. So, Is the cube root by itself? Yes, so now to get rid of a cube root, I do the,
Power.
the power.
Power.
Yeah, take the power.
I could only remember the word power.
That's okay. That's, you know what, that's enough. So as long as you remember that you're taking the power that equals this index right up here, this little number, you're in great shape. Okay? Well, what's 6 cubed?
216.
Oh, 216. And then once again, we're back into the realm of, oh, this is an easy number. Yep, add 21 to both sides. 237, I believe you. Again, the only way to make this more complicated is to keep adding stuff to it. Looking at just the left side, is the cube root by itself?
Yes.
Then I can raise everything to the third power. But now look at the right-hand side. I got something with a third root being raised to a third power, they cancel. So I'm going to cancel the root on the left, I'm going to cancel the root on the right. My left is this stuff, the right is that stuff, and then we're back to the equations that we're more familiar with.
So,
You want to collect the x's all to one side, so pick, do you want it on the left or on the right? Move things around until you get x all by itself. Yeah, subtract x from both sides. Turn the page, because the only way to make this harder is seriously just to add more stuff to it. First, look at 13. It's not anything I had a hand in unless I've typoed. There's way too many equal signs. Get rid of the equal 0. Val, if you don't mind, on 13, get rid of the equal 0. Flip the page. Hey, get your own pen. Here,
Thank
I
you.
need it back.
Yes, you-
Just for her to write with, not for you to, they stole my stencil is what happened. I'm explaining to you two because they didn't see what was happening. All right. 16, 17, 18 might be more challenging looking because the stuff inside of the cube root aren't just regular equations, they're now quadratics. So once you've cleared the cube roots, my recommendation is to handle them like your quadratics. So you're either going to get them equal to 0 so you can factor or complete the square or use the quadratic formula, or you're going to see stuff squared equals number, in which case you use the square root property to get rid of the square power. Okay? Does anyone want to see one of these three done? Yes, which one? 16. All right. Are the cube roots by themselves?
Yes.
Yes, so I'm going to raise everything to the cube power. You may hear it say the third power. That's also a way that we say it. The royal we of math people. It's a quadratic. So I can either factor it, complete the square, or use quadratic formula. Which of those three do you think you want to use? Which one's easier? That really depends on the numbers you're given and just how your brain works. For me, looking at this, I think I might want to try factoring first. I know I don't want to complete the square because looking at this middle number, completing the square is going to require me to divide that by 2, and it's going to create a fraction. And so it's going to be weird. But regardless whether we're factoring or completing the square or using quadratic formula, I have to get it equal to 0 first. So that's gonna be my first move. Yes, sir? Yes. Good eye. And now when I look at this, now completing the square seems simple because completing the square takes this number, which is even, divides it by 2, it keeps whole numbers. Which method do you want to see? All of them? Or the one that you're the weakest at? Okay, which one are you feeling the weakest on today? Factoring, completing the square, quadratic formula. Completing the square. All right, to complete the square, I need to move this number over here. Leave myself a space. Yes?
When you have a chance, please check your email.
Yes, ma'am, thank you.
Thank you.
I'm gonna take this middle number and divide it by 2, so it's a 6, and I'm gonna square it for 36. That goes here and here. Factor the left-hand side by taking this variable, this sign, and this number right here, not the squared, just the thing divided by 2. It's factored. Okay, completing square lets me factor that way. I'm just checking in on this portion, because it looked like I pulled a rabbit out of my hat. Right, looks like magic? Yes? So to factor it, this is completed the square, I took this variable and put it here. I took this sign and I put it there. And then this number, there, that's it. Okay, and then on the other side, as you were saying, it's gonna turn into 16. And now I have stuff squared equals number. To get rid of square power, I take the square root. So I'm gonna do the square root of both sides. Square root of 16 is? And then I need x by itself, so I need to do minus 6 to both sides. So I have two answers. I have x equals negative 6 plus 4, or I have negative 6 minus 4. This was a beautiful one to complete the square on. All right? Yep, yep. Because I did negative 6 plus 4, negative 2. And then I did negative 6 minus 4, negative 10. That's it. Right? It's super easy. That was all I had. Thanks, guys.
Bye.
Bye. I'm like waving at the camera like you can see me, right? Bye, camera that's focused on my handwriting.